Okay. So this is the part B or part two. In this part, I will discuss most probably all those properties, remaining properties and test. I will try to finish off tomorrow or day after tomorrow, the engineering geology part. So what happens is this is not a detailed course है ना. अगर engineer की बात करोगे, it will take like more classes to understanding all those properties. ठीक है, all those rock mass classification application all engineering geology की कैसे use होता है, all those application in the tunneling work for the construction of the dam. ठीक है, different type of dam terminology, different type of tunnel terminology. ठीक है, but thing is this is the completely kind of revision course. Whatever question is like arising continuously, that will be the most priority. ठीक है, जैसा मान लो टेस्ट हो गया, different type of test, lab test. Okay, all those basic properties. Okay, and rock mass classification, try to cover at least this part, at least within 2-3 days. ठीक है, practice some numerical है ना, remember some of the data और फैक्ट. जैसे मान लो कोई पूछ लिया कि व्हाट इज द वैल्यू ऑफ द कंप्रेसिव स्ट्रेंथ ऑफ द ग्रेनाइट रॉक ऑफ बासल्ट रॉक. सो फैक्ट बेस्ड क्वेश्चन भी आ सकता है ना, स्टेटमेंट बेस्ड क्वेश्चन भी आ सकता है. जैसे मान लो ग्रेनाइट का यूनिएक्सियल कंप्रेसिव स्ट्रेंथ हाई है ना, बासल्ट का टेंसाइल स्ट्रेंथ लो है, ऐसे स्टेटमेंट दे देगा. पूछेगा कि which one of the following given is correct or incorrect. ठीक है, ऐसे स्टेटमेंट बेस्ड भी क्वेश्चन आ सकता है. यू कैन गेट ऑल्सो न्यूमेरिकल. ओके, तो ट्राई टू कवर दिस ऑफ. So we discuss about how the rock measurement happen. What is the basic difference between the rock and rock mass? Tell me the what is the basic difference between rock and rock mass? क्या difference है बताओ. And one more thing I just want to say कि if you need some also give, like if you give some feedback uh, regarding the study or teaching methodology, if you want something from my side, then you can also give the feedback. What happens is the learning is a two-way process है ना. Suppose आपको समझ में नहीं आ रहा है, then there is no point view to telling everything, right? So you have to say sir ऐसे मत कीजिए, you have to add something or you have to teach like this so that it is better for the proper understanding. You can also give the feedback also, right? So it is your responsibility also, है ना. आपके भी कुछ रिस्पॉन्सिबिलिटी है, आपको निभाना पड़ेगा, एंड मेरे भी कुछ रिस्पॉन्सिबिलिटी है जो मुझे निभाना पड़ेगा. है कि नहीं बताओ. आर यू एग्री विथ मी और नो? We both were learning, right? You will learn something from my side, I will learn from you something, right? है कि नहीं बताओ. मुझे भी सीखना चाहिए आप लोग से, आप लोग से भी मुझे सीखना चाहिए, है ना. Yes or no? So tell me, what is the basic difference between the rock and rock mass? बताया था लास्ट क्लास में, rock and rock mass क्या डिफरेंस है एग्जैक्टली. Exactly, it is a completely aggregate of minerals, है ना. But rock mass, it is rock. No, it is not part. It is not part. Rock mass having like rock is there, having some the discontinuity or like plane of weakness or fracture within it, है ना. जैसे बताया था ना उस दिन. Suppose this is a terrain having some rock and you find some of the discontinuity present within it, है ना. So this is the rock mass. And in between those discontinuity you can get also just intact rock sample. बताया था, right? So plane of weakness जैसे fracture हो गया, bedding plane हो गया, fault हो गया, shear zone हो गया, right? So you can get the different type of discontinuity in rock. So that is called the rock mass, है ना. You can also field scale measure and laboratory measure. That means you get the different type of value or you can get the different type of properties in laboratory as well as the field. जैसे मान लो स्मिथ हैमर टेस्ट, राइट. So this is a स्मिथ हैमर टेस्ट. ओके, ये फील्ड में जनरली करते हैं, ठीक है. यू कैन गेट सम वैल्यू Okay, you apply load through this test है ना, स्मिथ हैमर कि थ्रू से आप कंप्रेसिव स्ट्रेंथ अप्लाई करते हो रॉक पे, जैसे मान लो ये रॉक है, यू अप्लाई द लोड इन द रॉक, you can get some the value or the compressive value, you can correlate with the empirical value and you can get the strength, right? I will go after that, not now, when I will cover the engineering geology in a detailed manner. I'll like cover all those things, है ना, जैसे लैब पे, ठीक है, if you are appearing the any type of examination has some requirement, right? You bring some black pen or like you mark the bubble like this, है ना, you bring admit card to the examination hall. Am I right or wrong? So every examination has some requirement, so like that every test has some requirement, है ना, for the conducting well manner test. So मान लो compressive test तुम conduct कर रहे हो lab पे, the compressive strength you are conducting in the lab have some requirement, okay, for the proper, मान लो कि कहीं पे तुम प्रॉपर काम कर रहे हो, यू हैव टू मेक इजी द लैब, जैसे मान लो लैब पे तुम इजीली कर पाओ कंप्लीट, तो इसीलिए कुछ रिक्वायरमेंट है, इसी तरह से आपको टेस्ट करना पड़ेगा, राइट? आर यू गेटिंग माय पॉइंट? सो एवरी टेस्ट हैज सम रिक्वायरमेंट, जैसे मान लो द लेंथ और विड्थ ऑफ द सैंपल, ठीक है, हाउ टू कंडक्ट द प्रॉपर टेस्ट, देयर इज सम द स्टेप टू बी फॉलोड, steps to be followed, have some flow chart in it, okay, having some the mathematical relationship or empirical value for the proper correlation of the test, है ना? So we'll look at this, okay. So this is the sample, rock sample written in the test, different type of test is there, I will not go through this. So this is the classification, slag durability test is there. What do you mean by durable? Tell me. ड्यूरेबल क्या है एग्जैक्टली? resist to deform, right? So durability is also a physical properties that helps to uh, get the strength value. If the proper durability is not there, that means this is a very low strength, right? If it is easily deformed, then a dam or a tunnel, any kind of construction should not be properly done, right? So this is the durability classification. I will go like how slag durability index test is there and what is the proper steps to follow, how it is, how do you get the index value, okay. I will go later part after the examination, ठीक है. Durability classification, जैसे मान लो 0 to 25, if the value will be 0 to 25 then it is very low, if the value is 26 to 50 then it is very low. This type of no data you can write in the GSI mains, not required for the any type of objective examination. This is for the GSI mains. At least you mention in the GSI mains examination, जैसे मान लो slag durability index पूछा है, you can write what is the slag durability index, what is the steps to follow, what is the condition to be applied, okay, what is the requirement for the test, and this is the durability classification scheme and durability index. How do you calculate the durability index, okay, the mathematical relation part. So abrasion resistance test, I will not go through this. So strength test, basically there will be the three type of strength test to be conducted. One is compressive, one is tensile, one is shear. Compressive मतलब क्या है बताओ? Pressurized, right? You apply the load, right? You apply the load. Compression, right? Push, that means you are pushing, right? Tensile matlab you are pulling the sample, right? Am I right or wrong? And what do you mean by shear? So this is the test, right? It is called the ring shear test. It is called the, for the tensile there will be the point load test and Brazilian test, ठीक है. And compressive, one is the uniaxial unconfined compressive strength UCS, and one is the triaxial compressive strength. Just remember this, I will not go detail in now, because like there are lot things to be remember how this is sampling. जैसे मान लो कहीं पे तुम फील्ड गए हो, ठीक है, you should follow some of the instruction for the collecting the sample, right? Just see, I have some really good sample. Are you looking my hand? See, what is this? Tell me. Just spin my screen. What is this? What is this sample? What? Dinesh? Is this a ore sample? Are you seeing or no? Is it visible my hand? Yes, exactly. It is core sample, right? You can get such laminated here. Laminated bedding plane is there. You can see, right? See, if you look at those, no, this is the length, right? If you see, so this is the length of the core. Are you getting my point? This part. Okay. If you see the cross section here, this part, circular section, what is this? This part. This is the diameter of the sample, right? If you see, this is a complete not properly sampled. जैसे मान लो ये ड्रिलिंग से डायरेक्ट सैंपल उठा लिए गए, ठीक है? See or no? So in lab what happens is you have to like properly orient the diameter, ठीक है? Are you getting my point? So polishing for the proper orientation. जैसे मान लो if you are doing the compressive test, just let me add. Still my health is not good. So if you are like doing the compressive strength test, this you have to remember, right? The length by diameter ratio of test. Make notes. जो बोल रहा हूँ ना, make note, because these are the sum of the data you should remember. This is really important. जैसे मान लो compressive strength कर रहे हो, the length by diameter ratio should be approximately 2 to 2.5, approximately. Okay, that means if you look the sample in my hand, that means length, okay, and diameter ratio, okay, should be 2 or 2.5. If the length by diameter ratio is not 2 or 2.5, okay, less than 2, then there are lot of like empirical relation or size correction to be done. There is some the mathematical relation. I will not go into detail. Mathematical relation, है, to make it the ratio L by D ratio should be 2 to 2.5, है ना? अगर 2 से नीचे आया तो कुछ एम्पेरिकल रिलेशनशिप है जो करेक्शन बोलते हैं, साइज करेक्शन. ओके, इट इज जस्ट अ मैथमेटिकल रिलेशन टू मेक इट L by D रेशियो शुड बी 2. इसीलिए हम साइज करेक्शन करते हैं, ठीक है? सो इफ यू लुक द सैंपल, सिलेंड्रिकल सैंपल, दिस इज द लेंथ पार्ट and this is the D diameter part. So this is the circular cross section, है ना? Circular cross section. Okay? And अगर sample correction के लिए जा रहे हो, suppose there are normally 3 type of sample we are getting. One is the regular proper orientation sample. One is the irregular sample. Okay. One is the block, prismatic or cubic sample. Normally we are getting. And for all those type of sampling, जैसे कोई regular sample मिल गया है field पे, ठीक है? There is some the like requirement for the conducting the test. If you are getting the irregular sample, there is some of the requirement or some of the method to be followed for the irregular sample. Okay, I will not go into detail because every test has lot of things. If you are looking the UCS test, then there are a lot of steps. There are a lot of mathematical relationship to be followed, and there are a lot of application is there. Okay, I will not go into detail. Just for time being, just remember the equation, mathematical equation. How do you calculate the UCS? Okay, clear? Are you getting my point? Tensile strength 2p by pi dl, where p will be the failure load, d will be the diameter of sample, l will be the length of sample. Okay, for tensile strength, remember for tensile strength test, the length by diameter ratio should be lie between 0.5 to 1. Are you getting my point? This value you should remember. This value, this is the data you should remember. Clear? So tensile strength can be calculated by 2p by pi dl. Okay. For the Brazilian, this is for the Brazilian tensile strength. Brazilian tensile strength. This is the formula or mathematical relation should remember for time being. ठीक है, हम बाद में डिस्कस करते हैं कैसा ओरिएंटेशन होगा. दिस इज द प्लेटिन. ओके, ब्लाजेरियन सैंपल का दिस इज प्लेटिन. यू अप्लाई सम लोड. ठीक है, जैसे लोड ये देख रहे हो सैंपल, सो यू अप्लाई द सम लोड. जैसे मान लो ये प्लेटिन है ना, ऐसे प्लेटिन रहता है लैब पे टेस्ट पे. यू अप्लाइंग सम लोड एट सम पर्टिकुलर टाइम, इट गेट डिफॉर्म्ड. सो दैट इज द स्ट्रेंथ at which load or at amount of load at which the rock will break or rock will failure. That is called the strength part. Okay, then there is some reading. You have to measure the strength and you have to take the failure load. Data read करोगे, ठीक है, reading, then you apply the new empirical relationship p by d square for the tensile strength, or like Brazilian test to p by pi dl. Okay, so you have to apply the mathematical relation or formula for calculating the tensile strength. Always remember, for the point load index test, p by d square, d will be the diameter, p will be the failure load. Are you getting my point or no? And shear test के लिए same 2p by pi d square. Always remember the formula for this time, particular time being के लिए ये सब याद कर लो. ठीक है, clear? Or any doubt you can ask. Any doubt? अभी टाइम नहीं है ना इतना सारा टेस्ट के लिए, अभी टाइम नहीं है. इफ यू लुक एट दिस, इट इज अ completely 6 semesters course, right? And how can you tell the everything, right? If you ever talk about self test, there is a lot. If like इंस्ट्रूमेंट सेटअप कैसे करते हैं, है ना, इंस्ट्रूमेंट सेटअप कैसे करते हैं, देयर आर लॉट ऑफ स्टेप्स टू फॉलो. सैम्पलिंग कैसे करते हैं, फील्ड कैसे जाते हैं, और सैंपल लेंथ कैसे, लेंथ बाय डायमीटर रेशियो अभी तो बता दिया 2:2.5. फिर कोरिंग कैसे करते हैं, ऑल दोज डिटेल्स एंड ऑल दोज स्टेप्स टू बी फॉलोड. लाइक देयर आर लॉट. एक क्लास में नहीं होगा. फॉर टाइम बिंग यू हैव टू रिमेंबर और यू हैव टू लाइक make notes out of it कि ऐसे ऐसे होता है, right? हाँ बताओ, any doubt? What is index test? What do you mean by index? Index is a kind of, you can say, physical properties. Okay, for the calculating of the physical properties, that is called the index. Okay, index strength. For the mechanical part or for the deformation part, there will be the some point load index test. That means index मतलब क्या है, indexing मतलब क्या है बताओ. index put करते हो ना तुम, when you like make presentation, you put the index मतलब final output. Okay, जैसे मान लो जियोलॉजिकल मैप पे, जियोलॉजिकल मैप दिखे हो ना, इंडेक्स लिखा होता है. व्हाट डू मीन बाय दैट? एग्जैक्टली, फॉर द रेफरेंस. you calculate the point load strength index, मतलब you are calculating the amount of strength, that is called index. Index is, you can say a simple word, value. Index is a value, point load index test. It is simply that test is point load. Are you getting my point? Test is point load, but from the point load you are calculating the amount of strength. Are you getting my point or no? हाँ बताओ. अरे yes, just like it is simply load. Point load is a instrument, simple, where you measure the strength. It is nothing like that. What do you mean by Brazilian test? If I will talk about Brazilian, क्या है? टेस्ट का नाम ब्राजीलियन क्यों रखा है बताओ? Exactly, right? From this instrument you measure the strength properties. Not exactly say, but you can say sometimes say, but not really. Actually ना इंडेक्सिंग वर्ड जो बोलते हैं, मैं बता रहा हूँ, सिंपली अभी बोला ना, फिजिकल प्रॉपर्टीज को बोलते हैं. फिजिकल टेस्ट जो बोलते हैं उसको इंडेक्स टेस्ट बोलते हैं नॉर्मली. बट इंडेक्स हम कैलकुलेट करते हैं थ्रू द एक्सपेरिमेंट. आर यू गेटिंग माय पॉइंट? We are calculating the amount of strength for that particular instrument or for particular method to get the value, some value. Okay, that is called the index. Clear? I'm not going into this part on confined compressive strength. Abhi bola, you have to make the sample like this, cube or cylindrical rock sample with flat and chord parallel faces. Abhi bataya na, if you look my hand, this is not really properly oriented sample. Okay, just drilling sample, utha liye sample. Okay, so this part you have to make polish and cut parallel faces, loading properly in flat steel platen, right? So sample diameter should be 50 greater than 54 mm. Okay, and also there is some of the standard, there's a ISRM standard and ASTM standard. What is this standard? What do you mean by ISRM? International Society of Rock Mechanics ना? जैसे मान लो WHO कोई वैल्यू दिया है, फ्लोराइड कंसंट्रेशन शुड बी लाइक दिस, राइट? वैसे ही ISRM, इंटरनेशनल सोसाइटी ऑफ रॉक मैकेनिक्स, गिविंग द स्पेसिमेन सैंपल साइज. स्पेसिमेन सैंपल साइज, द स्पेसिमेन सैंपल साइज शुड बी NX साइज उसको बोलते हैं, दैट इज अप्रोक्सीमेटली 54 mm. ओके, the specimen size should be approximately 54 mm by ISRM standard. इसलिए उसको standard बोलते हैं, ISRM standard. Okay, one is the NX size. This is very much important. That is called the 54 millimeter. There are like other also AX size बोलते हैं, ठीक है? The size will be the 28 millimeter. BX size है, then EX size है. This should not be follow for the coring or collecting all the sampling. ठीक है? The size should be 54 millimeter. This is NX size by, इसको बोलते हैं ISRM standard. The specimen size should be or a diameter should be 54 mm. This is diameter. Okay, specimen diameter should be 54 mm. Clear or any doubt? Rock Mechanics International Society, this is called Society of Rock Mechanics. Okay, this, the diameter of the sample should be followed by ISRM standard को follow करते हैं. Normally the specimen diameter should be 54 mm. Apart from this there are a lot, like AX size है, that is 28 mm, BX size है approximately 41 mm, right? EX size है 23 mm, but this should not be follow. अरे इसको रेफरेंस लेके बनाया है. How will I say? जैसे स्पेसिमेन नेमिंग देते हो ना, सपोज यू गेट फ्रॉम द सैंपल, इसको बोल दिए NX, यू कलेक्टिंग समवेयर, राइट? द सैंपल नेम इज लाइक दिस. जैसे तुम फील्ड गए हो, ठीक है, कोई रॉक मिला ग्रेनाइट सैंपल, तुम उसको डालते हो ना, S1 सैंपल लिखते हो, साइड में ग्रेनाइट लिखते हो, है ना, नहीं तो ऐसे नोमेनक्लेचर बोलते हो कि पर्टिकुलर सपोज कहीं पे पुणे में सैंपल उठाए हो, पुणे S1 ग्रेनाइट ऐसे लिखते हो, राइट? दिस इज जस्ट ए नोमेनक्लेचर, नथिंग लाइक दैट। ओके, सो ये सब हम नहीं जाते हैं अभी के लिए, जस्ट रिमेंबर ऑल दोस फॉर्मूले, ठीक है। आई विल नॉट कवर बिकॉज दिस इज अ ह्यूज टॉपिक, राइट, एंड आई विल नॉट गो। सी द पॉइंट लोड स्ट्रेंथ, IS इसको बोलते हैं, और पॉइंट लोड इंडेक्स, ओके, पॉइंट लोड इंडेक्स फॉर द कैलकुलेटिंग ऑफ द स्ट्रेंथ प्रॉपर्टीज। इंटैक्ट सैंपल बोल दिया था मैं, क्या है इंटैक्ट सैंपल? Okay, these are the some of the laboratory tests. Tension stress, shear stress, flexor test is there, that is called the beam bending test, है ना? In the beam bending test, the sample length by diameter ratio should be approximately 6 to 7 ऐसे कुछ है, I don't exactly remember, but approximately 6 to 7, because the length should be greater, right? The length should be greater in the bending test, so that it can easily get bent. And some of the elastic modulus test is Brazilian हो गया, bending test हो गया, and some of the deformability test is there, right? Or not go into detail physical mechanical property, उस दिन बताया था, physical is all about the physical appearance, right? Physical interpretation, and mechanical all is about the stress part or deformation part. Okay, rock mass then बता चुका हूँ. This is the intact rock. If you having some the discontinuity, or if you there are a lot of fraction in it, you can get the sample. So this is the intact rock. That means the rock doesn't have any kind of the discontinuity in it. No? This is the intact. These are much fractured rock. Okay. So this you have to remember. This is really important. There is rock mass classification by, one is the RQD. I will go tomorrow this part, rock mass classification part. RQD है. What do you mean by RQD? Can anyone tell me? RQD क्या है? Anyone? Rock quality designation. What is mean by that? Rock quality designation. Exactly. Quality check है. There are a lot of classification of core sample is there. ठीक है, but I will tell about the how to calculate the RQD tomorrow. Okay, tomorrow. And RQD simply to measure the quality of the core sample. Simple word. To make the quality of the rock sample for the construction of the like tunnel, right? Whether this type of rock is suitable for the construction or not. That is called the RQD. I'll go into detail tomorrow. Okay, and some of the geomechanic system like RMR, Bioinsky. ठीक है, ये याद रखना. This is the fact ways you should remember कि RMR कौन दिया था? Bioinsky, given by the Bioinsky. Okay, also called the Bioinsky classification system. Okay, Q system कौन दिया था? Barton, right? Given by the Barton. Norway Geotechnical Institute दिया था Barton. ठीक है, GSI by Cook, Geological Strength Index. We'll go into detail tomorrow. Okay, Q system Barton ने दिया था, Geomechanic system RMR Bioinsky ने दिया था. Okay, and GSI दिया था Cook, given by the Cook. Okay, and rock mass rating simply there are simple, ये भी quality check है, just to quality of the core sample. Okay, and it depends upon the 5 parameter. जैसे मान लो RMR का rating होता है, जैसे class 1 division, 2 division, 3 division. अगर 1 है, then whether this type of rock is very weak, or whether this type of compressive strength is very high or very low, this type of classification is there. This is called simply classification scheme. Okay, RMR. So it depends upon the unique cell strength of the core sample. Okay, rock quality designation, RQD, spacing of discontinuity, condition of the discontinuity, and groundwater condition. Okay, if there will be the presence of the much of the groundwater is there, then the strength will gradually decrease, right? So based on that, or based on the groundwater condition, there will be some of the classification. Okay, so based on that classification, we'll just measure the strength of the rock. Okay, if the presence of the discontinuity is there, much discontinuity is there, then the strength will gradually decrease. So accordingly, the condition of the discontinuity, the rating will vary, है ना? अगर spacing ज़्यादा है, अगर spacing कम है, whether the RQD will be the higher or RQD will be lower, based on that there will be rock mass rating. एक rating दिया होता है ना? So that is called the RMR, and RMR will be the sum of the all those property. जैसे ये मान लो R1 है, ये 1 है, ये 2 है केस, so सबको ऐड करते हैं. ठीक है, adjustment of the joint orientation relative for the construction work. Don't go into detail. This part is just a classification scheme or empirical relation between all those parameters, जैसे joint spacing and what is the RMR value. So we just measure the empirical relationship. Don't go into detail for time being. Next, move to this. Okay, just remember the formula. What is the Q? Okay, so RQD upon Jn. So Jn will be the joint set number, Gr will be the joint roughness number, J will be the joint alteration number, Jw will be the groundwater condition. ठीक है, SRF will be the stress reduction factor. Okay, RQD will be the rock quality designation, number of joint set, roughness, discontinuity, and groundwater condition is there, stress reduction factor is there. Okay, then we will calculate the Q rating. Just remember the formula for time being. Okay, when I'll discuss about much engineering geology, then I will discuss all those things. Okay, जैसे मान लो ये look this. Okay, based on the number of set discontinuity joint set, if it is massive, then a rating will be 0.5, 1 set, 2, 2 set, 4. So based on this we can calculate the final output. ठीक है, अगर Q value simple, अगर Q value less than 0.01 होगा, it is exceptionally poor. The quality of rock mass will be exceptionally poor. ठीक है, if the 0.01 to 0.1 it is extremely poor. If it is less than 400 it is exceptionally good. So based on this parameter or based on the this indexing, ठीक है, so we normally check the quality, है ना? Based on this there are a lot of construction, there is a tunneling work पे normally we use करते हैं for the construction of the tunnel. So based on this हमको अगर poor rock mass मिला, then we cannot construct the tunnel in that rock mass, right? If the strength or rock mass will be the higher or Q value will be the higher, then construction should be properly conducted, right? So this is all about this rating part. बता चुका था, ये बता चुका हूँ physical, yeah. Before that I'll just revise some of the things. What do you mean by porosity? Last class पे बताए थे. And what is meant by the void ratio? It is calculated in percentage. Void ratio क्या है? Void volume. Then what is the relationship between the porosity? बताओ, 1/1 phi equal to E of M और E equal to how do you calculate? अगर सपोज मान लो कहीं कंडीशन पे ये फॉर्मूला आपको याद नहीं है, then you have to calculate also. कैसे हुआ है? कैन एनीवन से मी? बताओ कैसे कैलकुलेट करेंगे? पाई दिया हुआ है वॉल्यूम ऑफ वॉइड, बल्क वॉल्यूम, E will be volume of void by solid volume. कैसे फाइंड आउट करेंगे? ओके देन टेल मी. बेबी इसको अगर इन्वर्स करेंगे तो बीबी प्लस बी एस बाई बीबी होगा, है कि नहीं? सो 1 by v 5 pb upon bp will be 1, right? Are you getting my point? And bs by bb. Okay, are you getting my point? So 1 by 5 equal to 1 plus इसको भी लिख सकते हैं इन्वर्स करके 1 by bb by bs. Are you getting my point? 1 by phi equal to 1 plus 1 by e. Am I right? So 1 by phi will be e plus 1 by e. Are you getting my point? So 5 will be e by 1 plus e. है कि नहीं बताओ? ओके अगर कहीं पे रुक गए, this should be this is actually for the rock sample. Same. Why I am adding this is called the phase behavior of the rock. It is called the phase behavior of rock. This is really important for the understanding of the physical property of rock. Suppose ये rock sample है ना? You can get some of the rock. In between rock you find some pore space. Yes or no? बताओ. You find some of the pore space. The pore space will be filled either with water or air. है कि नहीं? सो हमको इसको क्रॉस सेक्शनली दिखा दिया है, ठीक है? सपोज सम ऑफ द पार्ट विल बी सॉलिड, सम ऑफ द पार्ट विल बी वाटर, सम ऑफ द filled with the air. Are you getting my point? So this part air plus water will be void. Yes or no? So water plus air will be void. So this is the void part, ठीक है? And this part solid part is only for the matrix or solid grain. Yes or no? Yes or no? Clear? इतना clear है? Suppose the solid volume will be Vs, okay? Water volume will be Vw, air volume will be Va, ठीक है? And Va plus Vw will be Vb. Yes or no? Yes or no? And total volume जैसे Va plus Vw and solid volume will be total amount of volume, that is bulk volume V. Clear? So this is the volume part, ठीक है? Now comes to mass part or weight part. Okay, let's assume the weight of water will be Ww. Air water नहीं है normally, air water normally mass will be 0, right? So water का weight होता है Ww, solid का weight होता है Ws. Same as water solid, for the water weight of water will be the bulk weight W. Clear? इतना clear है और नहीं है? So accordingly that you can calculate. Suppose मान लो मैं पूछूंगा what do you mean by density of solid? क्या होगा? Mass of solid upon density of rock. Whether it is a bulk volume or like solid volume. Is it bulk? Vidushi, you tell me. Is it bulk or solid volume? Density of rock will be mass upon the volume, है कि नहीं बताओ? ये bulk rock sample है. Robi, what is your opinion? बताओ. Why? Tridev, any other take on this? Why it is solid? Why it is bulk? Density of solid. Tell me. This part I am talking. This part I am talking. Why it is bulk? Why it is solid? If I am talking about solid density, bulk में तो mass upon total volume होता है. What about the solid? मतलब grain अगर होगा present, if I will talk about grain density, that means solid density. Typically क्या होगा? Mass of solid upon क्या होगा? Volume of tell me क्या होगा त्रिदेव? Sample का think about it. If if you remove the water and air, okay, then what is the consequence in the density, or how it will affect in the density? Density decrease, right? That means all the water will gone. Yes or no? So how it will affect in the density of the grain? कैसे affect करेगा? Trideep, what is your answer? Exactly, right? So now you tell me what should be the answer in the denominator part? Density of solid. Trideep, ball क्या solid? Exactly, it is not bulk. Density of what does mean by density of solid or bulk density? Mass upon volume है कि नहीं? Density of solid मतलब क्या है? Then you exactly right. That means you just dry the sample. Sample को तुम dry कर दिए हो. There is no water or there is no void space in that. Right? That is called the oven dry condition. You dry all the sample, right? Or from sample you extract the water and void. Are you getting my point? So density हम discuss किए थे. Bulk, unit weight. What is unit weight? Bidusi? Bidusi, you tell me. I discussed on the last class. Unit weight क्या होता है? Trideep, are you there or left? Okay. Weight by open unit volume, right? W by V will be the unit weight. It is called gamma, right? We discussed in the last class also. So some of the most rocks have the density between 2500 to 3000 kg per meter cube. The unit will be kg per meter cube. है कि नहीं बताओ? So this should be remembered. This is very fact. Most of the rocks have the density between the. What is the difference between density and specific gravity? Specific gravity. वेट पर यूनिट वॉल्यूम बोला मैं कहाँ बोला है यूनिट वेट अपन यूनिट वॉल्यूम वेट अपन यूनिट वॉल्यूम बोला ओके स्पेसिफिक ग्रेविटी एंड डेंसिटी के बीच में डिफरेंस क्या है specific gravity and density. Density is rho, specific gravity. Exactly, specific gravity with respect to, so it is called the, इसको बोलते हैं relative density also, right? Specific gravity को you measure with respect to the water, right? So density of sample upon the density of the water, and density is simply mass per volume, है ना? The density has some unit and specific gravity doesn't have the unitless. Yes or no? So, okay. So density, unit weight of solid, right? So this you should remember, okay? Porosity and the dry density, relative density, right? This should be remember. Moisture content क्या है? So this is the phase diagram. So this is the amount of water. This is for the mass part. This is for the volume part. Okay. So mass of water, mass of solid, mass of air will be 0. So volume of water, volume of water, sorry, volume of air, volume of water, and volume of solid. And all this is total volume. All this is the. So moisture content will be the amount of water upon the amount of solid. Okay. So this is called the moisture content. How much moisture is there in solid sample? Are you getting my point? Or mass of water upon mass of solid. Are you getting my point? कितना moisture है solid पे? Clear or any doubt? So natural moisture content of rock sample is the moisture content of sample when it taken from the ground due to excavation or boring. Okay, so you extract some of the sample. Okay, how much moisture content will be there in the sample? Okay, so moisture content is determined by noting the loss of weight of sample after drying it 24 hours. Suppose sample ले आया इसको dry किए हो and what is the loss in the weight? Suppose एक sample ले आए हो इसका weight W1 है. After you oven dry or completely dry, you get some of the weight. Yes or no? So simply, what is the amount of weight loss? W2 minus W1. Are you getting my point or no? So that is called the moisture content, the amount of moisture in the sample. You can get by this relationship, mass of water by mass of sample. Clear or any doubt till now? अभी तक कुछ समझ में नहीं आया तो पूछो. If you have any doubt, clarify your doubt. हम क्या क्या पढ़े? सिंपल, पोरोसिटी, क्या क्या पढ़े बताओ? डेंसिटी, स्पेसिफिक ग्रेविटी, दिस ऑल द फिजिकल प्रॉपर्टी है ना. और क्या क्या पढ़े? मॉइस्चर कंटेंट, हाउ टू, relative density, so that is called the specific gravity, relative density, unit weight of rock. Yes or no? Okay. So degree of saturation, volume of water in the volume of void. How much of the water in the void space? That is called the degree of saturation. That means all the sample is saturated or not. That means all the void space is filled with water or not. Are you getting my point or no? कोई डाउट है? विदुषी, रूबी, त्रिदेव, any doubt you can ask. जैसे मान लो अगर फेज डायग्राम पे ड्रॉ करूंगा, लुक एट द फेज डायग्राम. ये सॉलिड पार्ट है कि नहीं? ये वाटर है, ये एयर है, ठीक है. सो दिस इज partially saturated rock. Yes or no? If it is completely saturated, that means all the air should be filled with water. Yes or no? That means the phase diagram is look like this. Solid is there and water is there. समझ में आ रहा है? So this is called the saturated condition or saturated sample. That means all the void getting filled with water. Clear or no? So that means what is the volume of water? It is called the volumetric condition, not mass. Volumetric condition. So how much volume of water is filled with void? So volume of water upon volume of void will be give rise to saturation. Clear? If it is completely saturated, 100% AS will be 1. Yes or no? If it is completely dry, AS will be 0. समझ में आया या नहीं? So S will be the degree of saturation, BW will be volume of water, BV will be the volume of void space. Clear or नहीं? Permeability. What do you mean by permeability? Exactly. Flow. Ability of flow or transmit. Okay, how it can easily flow, that is called the permeability. Okay, are you getting my point? If you see, and also called it is called the effective porosity. The effective porosity that contributes the permeability. है ना? अगर पोर्स स्पेस के बीच में कुछ कनेक्शन नहीं है, if there is no interconnection between the pore space, that means the water or fluid cannot flow easily. Are you getting my point? That means that material will be the non-permeable. है कि नहीं? If there is enough space or interconnection space, suppose this is the pore, you can get easily flow. The amount of fluid can easily flow. So this is called the permeable. Yes or no? So there is this enough space in between the grain. Clear? So permeability is the measure of ability of material to transmit the fluid. Most rock, including igneous, metamorphic and chemical sedimentary rock, generally have low permeability. Shale का normally low permeable है. It is low permeability. Are you getting my point? Why it is low permeable? It is fine grain. Shale is porous but not permeable. Clay, shale, it is porous and non-permeable. Tell me, tell me why it is non-permeable. It is porous, but any effect the other way around. This is not proper like clarifying the non-permeable condition through the ionic effect. Okay, Vidushi, you tell me. Exactly. Vidushi, you tell me what should be the answer. Why it is non-permeable? Are you there or left? No there. Trideep, tell me. No one is there or I am not audible? Why it is? What happens, dude? If it is fine grain, then what will be the consequence? क्या होगा? Fine grain होगा. It is closely spaced, right? Then that means the pore throat is small, right? The pore throat is small. If the pore throat will be small, there is no proper flow in the grain. Yes or no? So that should be the proper answer why it is non-permeable, all the fine grain material. Okay, porous rocks such as sandstone usually have in the high permeability. Okay, while the granite have the low permeability because it is massive. Okay, and non-porous. See, this is the non-porous and non-permeable condition. There will be the no interconnected pore space in between the grain. It is porous and non-permeable. There will be the enough pore space is there, but all the grain in between the grain there is no interconnection. Okay, and it is porous and permeable. The fluid can easily pass. So this is the interconnected space in between those. So all this is type of three condition: non-porous, non-permeable, porous and non-permeable, and porous and permeable. Clear? And some of the electrical properties. Okay, why it is so much important in the electrical properties? Because it measures the electrical resistivity of the formation, है ना? Electrical resistivity of formation. The electrical resistivity property is very much useful in the groundwater exploration. है कि नहीं? For the electrical properties, you measure the dielectric constant of the rock. Measure the dielectric constant for the proper data interpretation. Okay? It is mostly used in the groundwater exploration. Clear? So this is the physical property. Electrical property is the physical property. Physical properties. Next, go to thermal properties. Same, the thermal conductivity should be measured. You know, right? When you go below the earth, what is the geothermal gradient of earth? Geothermal gradient क्या है? 25 to 30 degrees, 25 to 30 per kilometer, right? So if you go depth below 1 kilometer, if you go to the 1 kilometer, the temperature should rise to 25 degree. Are you getting my point or no? So the thermal properties tells about the geothermal gradient, okay, and the thermal conductivity. Okay, thermal conductivity properties of the rock. Okay, so increase in the temperature makes the rock weaker due to the formation of crack. If there will be the enough cracks, then the temperature increase makes the rock weaker in the rock mass. So thermal properties are more important to the engineer, especially for the tunnel designing work and other the underground work, opening underground powerhouse work type of things. Temperature changes induce the, so this is the basically a mathematical relationship. Don't go into detail. So Q is the amount of heat transfer in perpendicular direction through one area, okay, of the sample. T2 minus T1 will be the temperature difference in degree centigrade between 2 points at a distance x. Clear? Don't go into detail, just understand the thermal properties of the rock. Are you getting my point? No. ज़्यादा स्पीड हो रहा है क्या? If like I will go in a speed way, then you can also stop me, right? Sir, speed हो रहा है, just go little bit slow. You can also raise your voice also. ठीक है? ये करो, ये असिस्टेंट जियोलॉजिस्ट पे आया था 2022. What will be the answer? Ruby, what will be the answer of this question? The Boyd ratio will be approximately, right? So Boyd ratio is asking equal to 5 by 1 minus 5, right? So it is 0.4 by 1.4. So 0.4 by 1 minus 0.4 will be 0.6. कितना होगा? It is 4 by 6 है ना? 2 by 3, 1 by 3 will be कितना? 33% into 2.66. Robi, are you getting my point or no? आप लोग है कि चले गए या? I don't exactly know. Huh? If you have any doubt, like understanding the concept properly or not, just tell me. I'm continuously asking you are like there or not. Just tell me. See, in the class, no, whatever you know, even if the answer will be wrong, tell me. Even if the answer will be wrong, अगर ऐसे whether you are not responding, then the class will be somewhat boring, right? It is not interesting at all. है कि नहीं, बताओ? Understanding, no, this question कैसे हुआ, समझ में आया? Bart ratio. Next go to the mechanical properties. Okay, mechanical properties is like attribute for the deformation. This is called the deformability properties. Like you deform some of the sample to measure the strength or cohesion value, है कि नहीं? You measure the compressive strain, that is called the uniaxial or triaxial. You measure the tensile strain. All these are the deformability properties, right? How do you apply the load and how the sample will fail at a certain condition. Strength क्या है? कल बताया था मैं उस दिन. Strength क्या है? It is also pressure by area, right? It is also pressure by area. So amount of load it can take. What is your strength? Suppose आप 10 किलो उठा पा रहे हो, that means your strength will be 10 kg, right? I mean, are you getting my point or no? Then अगर 10 किलो से ज्यादा तुम उठा लोगे, then somewhat your muscle get fatigue, pain होगा, yes or no, बताओ? That means your muscle get failure after the your strength, है कि नहीं? So when the strength will be less than the stress, or that means the stress will be higher than the strength, then failure occurs, yes or no? The rock will fail after this, yes. So some of the cohesion value and friction angle you can get from the Mohr Coulomb diagram. Shear strength, क्या हम बताए? I don't exactly get your point. Maximum stress, still I am not getting your point. Maximum stress अप्लाई कर रहे हो, बट कैसे नहीं शो करेगा? You know the stress strain relationship. Just let me add some of them. You know the stress strain relationship. Let's revise. Stress is directly proportional to the strain, right? Stress is equal to having sum of the constant into strain. So this constant is called the modulus or moduli, right? Be it Young's modulus, be it bulk modulus, है ना? Young's modulus, rigidity modulus, है ना? So bulk modulus, Young's bulk modulus is for the volumetric strain, है ना? Bulk modulus. Young's modulus will be the for the linear strain. Rigidity modulus for the shear strain. Are you getting my point? So Young modulus मतलब strain मतलब क्या है? Exactly, the stress का जो response है, that is called the strain. But actually meaning क्या है? The change in length or change in shape with respect to the original length. Yes or no? E will be change in length upon length. So that is called the linear strain. Yes or no? So this strain or this moduli will be the bulk modulus. Sorry, Young's modulus, not bulk. Bulk is for the volumetric strain. Bulk modulus will be the change in volume upon original volume. Clear? So ये जो relationship है इसको बोलते हैं Hooke's law, है कि नहीं? Go slow. So same Poisson's ratio will be the ratio of the lateral strain to the longitudinal strain. ठीक है? Suppose मान लो ये example है. You put stress. Okay? The stress gradually what happens is there will be the sum of the volumetric change in the sample or no? आपको समझ में आ रहा है? If you have any doubt, ask me continuously. कि समझ में नहीं आ रहा है? Even if you ask twice or thrice, I will explain. Suppose ये example है. You putting sum of the stress. There will be the volume change or not. The stress, the sample will reduce in size. Yes or no? Like this. So what is the change in length across this and change in length across this? Clear? So this will be tells about the Poisson's ratio. Exactly. Lateral, right? Ratio of the lateral strain to the longitudinal strain. Lateral मतलब क्या है? Lateral direction क्या है? Exactly, right? This is the lateral part, na? This is called lateral part. This is called the longitudinal section. है कि नहीं? That means axial. Are you getting my point? Trideep, are you getting my point or no? If you have any doubt, you can ask. X upon y, exactly. Young's modulus will be the ratio of the longitudinal strain to the longitudinal strain part. Okay. And deformability, elasticity, and plasticity will be there. Elasticity मतलब क्या है? कितना resist कर रहा है, right? Exactly. When you apply continuously load in the sample, then after some point it will come back to the original condition. Elastic material, right? It will come back. It will not get deformed, right? The limit of deformation up to which the material is elastic. है ना? Elastic material, rubber, you pull it, right? When you pull it, it can come back to the original position. Up to that limit or up to that particular elastic limit, the material is elastic. After that, there will be the deformation take place. Yes or no? ये diagram पढ़े हो ना? So this is up to the elastic limit. Stress versus strain diagram. Up to this, the material will be elastic. After that, there will be the sum of the deformation like this or somewhat the relationship change, right? So this is called the plastic deformation. ठीक है? Plastic deformation मतलब क्या है? Material you cannot get back to the original position. Material permanently get deformed. Okay. Compressive strength, either the uniaxial or unconfined compressive strength, because in one direction you are applying. That means along that axial direction, if you see this sample, so it is unconfined because this is not confining in this direction. You are applying load in a certain direction. ठीक है? So that is called the unconfined compressive strain. मतलब in the particular one direction you are applying the stress, but in the triaxial stress you are applying the every direction. ठीक है? So that is called the triaxial compressive strain. UCS is given by the ratio of the load failure to rupture the cross sectional area. ठीक है? So sigma C will be the P by A. Okay, if the length to diameter ratio of the rock specimen is less than 2, then measure the compressive strain. CA should be corrected. That means there will be some size correction parameter. Okay. I don't go into detail. Okay. When I will cover the engineering geology, then I will detail. I'll confuse you. What is the triaxial compressive strain? For time being, just remember the only formula how it is applied this way. The in the UCS, this is called the UCS test. In the UCS, the load will be applied axially or in one direction. Okay? But in a triaxial, there will be the triaxial setup. You should understand the triaxial setup. Then you can find out the triaxial compressive strain. How it is completely. Not three axes actually. One parameter will be morely added. You can get such the fluid pressure in that fluid pressure. Okay. For that you have to understand the setup first for the triaxial compressive strain. ठीक है, आपको सेटअप समझ में आना चाहिए. देन यू हैव टू अंडरस्टैंड द ट्राइक्सियल कंप्रेसिव स्ट्रेंथ पार्ट. ठीक है, डोंट गो इनटू डिटेल फॉर टाइम बिंग, क्योंकि एग्जाम पे नॉर्मली ट्राइक्सियल कंप्रेसिव स्ट्रेंथ नहीं आता है. ठीक है, सो सिग्मा एस विल बी पी बाई ए. टेंसाइल स्ट्रेंथ सेम, you like pull apart, sample will break. Just remember the tensile index, tensile strength, mathematical relationship, just remember. Okay, so strength, don't go into detail. So P by D square will be the point load strength, the length by diameter C. All those having set up, having some of the condition is a मान लो length by diameter ratio should have the fix for the diametrical test should be greater than 1. Okay, in the point load strain I already mentioned, in the point load strength the length by diameter ratio should be greater than 1. Okay. So point load test of rock was conducted diametrically and axially. It is both way. In axial direction you can also put, in the diametrically if you like put sample like this, you can also get some of the strength. Okay, elasticity same. After some of the like part, the material will be the elastic material. Okay, then it will permanently deformed. From this slope you can get the modulus of elasticity. Okay, stress upon strain diagram. See this part, this is called the linear relationship between the stress and strain. As stress is directly proportional to strain, so it is shows the linear relationship. No? So the constant will be K, that may be Young's modulus, that may be bulk modulus, I will say. Okay, and rate of change of strain is a function of stress is known as the modulus of elasticity. अभी बताया. That means change in length by original length, bit it change in volume by original volume. Okay, that is called the modulus of elasticity. That means the rate of change of stress as a function of the stress. Okay, इतना तक किसका डाउट है तो पूछो. Don't go into detail. This is called the indirectly determination of the elastic parameter from P and S wave. Don't go into detail. This is not required for the examination. How will passing through the P wave and S wave. So this is called the velocity meter. और इसको बोलते हैं पुंडित टेस्ट बोलते हैं इसको. Okay, don't go into detail. From this measurement, the elastic parameter can be observed also. P wave and S wave velocity measure करते हैं particular rock sample का by passing through the P wave and S wave. All these are the elastic parameter. You measure the elastic modulus from this. Any doubt till now? Don't go into detail for the time being, because what happens is, जैसे मान लो पुंडित एक टेस्ट है, you have to cover all those things regarding the पुंडित, कैसे पास होता है, ठीक है, how the sample should be placed. Okay, see, there will be some of the emitter, some of the receiver, where the sample जैसे मान लो, sorry, क्या बोलते हैं उसको, the amount of reading can give through the receiver, right? So sample should be placed like this. So there are a lot of instrumental setup, lot of mathematical relationship for the particular test is there. Don't go into detail for time being. Any doubt till now? You can ask. Any doubt? Trideep, Ruby, Vidushi, if you have any doubt, you can ask. No doubt? So P wave velocity can be calculated by this relation. Zero wave velocity will be, you know, right, rigidity modulus upon density का root over Poisson solid normally 0.25, maximum will be 0.5. Poisson's ratio होता है normally, एंड मॉडुलस का रिलेशनशिप ये होता है, जस्ट रिमेंबर द फॉर्मूले यू कैन गेट, राइट। सपोज मान लो कहीं पे फॉर्मूले पूछ लिया, पी वेव वेलोसिटी, ठीक है, कैलकुलेट द पी वेव वेलोसिटी गिवन बल्क मॉडुलस दिया होगा, यंग्स मॉडुलस दिया होगा, ठीक है। हाउ कैन यू गेट इट बाय द अप्लाइंग दिस फॉर्मूले। सपोज रिजिडिटी मॉडुलस दिया है, डेंसिटी दिया है, हाउ कैन यू कैलकुलेट द zero वेलोसिटी, जस्ट remember the formula only for time being. Okay, now you tell me these two, tell me, अगर सारे कुछ समझ में आ गया then tell me this, these two question बता। वही तो ना आप लोग को, आप यू लाइक डोंट मेक नोट्स और व्हाट। मैं हमेशा ही बोलता हूँ कि सपोज ए टीचर गिविंग द एफर्ट 50-70%, then it is your responsibility putting the 100% effort in the class as well as in the home. Tell me the comprehensive UCS. First UCS, tell me. Vidushi Rupi, tell me. What is the formula mathematical relationship for the calculation of the UCS? मैं हमेशा भी बोलता हूँ whenever I like providing the lecture, make notes. जब तक लिखोगे नहीं ना तब तक समझ में नहीं आया, जस्ट पुट ए नोट्स, शॉर्ट नोट्स की UCS, हाँ पोरोसिटी ये है, बॉयड रेशियो ये है, एटलीस्ट मेक नोट्स। हाँ बताओ। Exactly, that is the tricky one, right? If it is the NXi score, then the diameter should be, बोला ना, there will be some ISRM standard. In ISRM standard, it is called the NXi score or NXi specimen. The diameter should be 54 mm. Okay, this is ISRM standard. Other is AXI, लिखा चुका हूँ already. It is your responsibility to make notes out of it. मैं हमेशा ही बोलता हूँ, दिस इज इन क्लास, जस्ट पुट योर फोकस इन द क्लास, मेक नोट्स आउट ऑफ इट, इट विल बी हेल्पफुल व्हेन गो आउट ऑफ द क्लास, जस्ट रिवाइज दोस इंपॉर्टेंट पॉइंट्स। हमेशा याद रखना, मेकिंग योर ओन नोट्स, ओके, प्रैक्टिस अ लॉट, revise thoroughly, that will only help. किसी दूसरे का नोट्स, जैसे मेरा नोट्स आप बना लिए, the notes is like completely understanding of the my parts only. किसी दूसरे का नोट्स will not work for you, trust me, it is completely your responsibility for the making notes own. And आप नोट्स को कैसे रिवाइज करते हो, दैट विल हेल्प, ओके। सो NXi स्कोर का डायमीटर 54 mm है। मैं हमेशा बोलता हूँ, क्यों बोलता हूँ, देयर इज सम रीजन, राइट, इट्स कंप्लीटली लाइक रिपीटिंग many times, make notes in the class, right? Properly, your mind should be in the class only. Be focused in the class, make notes, ठीक है, it will help. देखना ग्रेजुअल, ट्रस्ट मी, ये 10 days 15 days करके देखो, ग्रेजुअली योर इम्प्रूवमेंट होगा, ट्रस्ट मी, एंड ग्रेजुअली कॉन्फिडेंस बिल्ड होगा। अगर नहीं होगा तो मुझे बोलना 10-15 days करके देखो, इफ डजंट हेल्प देन टेल मी कि सर आप रॉन्ग बोल रहे थे। कॉन्फिडेंस, जैसे मान लो मैनी स्टूडेंट लाइक आई गॉट मेल, लाइक सर कॉन्फिडेंस नहीं है, कैसे न्यूमेरिकल सॉल्व करें, कैसे ये करें, कैसे वो पढ़े। द कॉन्फिडेंस विल कम ग्रेजुअली, not like in a single day. You feel confident after like certain days. जैसे हर rock का having some the strength, having some compressive strength. After that the rock will fail, right? So same as आप लोग के भी confident gradually build होगा after certain time के बाद. Okay, जो भी है, calculate this. It is simple, right? P by A. The load will be in the kilonewton, 90 kilonewton. ठीक है? And area आपको calculate करना पड़ेगा. क्या? Compressive strength. What is the formula? Ruby, you tell me. What is the formula for this? Pressure by area, right? ये देखो यूनिवर्सल कंप्रेसिव स्ट्रेंथ क्या लिखा है, P by failure load of an area. कहाँ लिखा है? That is called the tensile strength, no? Tensile strength and shear strength also. Shear strength का 2p by pi dl I think. Go back to the lecture and calculate this. Okay, this is just a formula, please go through this. ठीक है? And Brazilian test direct दिया हुआ है. ठीक है? The tensile strength of the rock Newton per. Even if you don't know in this question, अगर ये क्वेश्चन पे आप लोग का फॉर्मूला भी याद नहीं है, then you can easily solve in this question. See, asking in the Newton per millimeter square है ना? What is the Newton in the this part? This part है कि नहीं? 5 kilonewton. So convert into the Newton. 5 into 10 to the 3 Newton by millimeter square. Then this is slightly tricky कि ये square होगा ये या फिर क्या होगा, because the data is 2. ठीक है? So pi dl डाटा 2 दिया हुआ ना, so just multiply with d and l with pi. So this is called the Brazilian tensile strength formula क्या होता है Brazilian का? 2p by pi dl, right? So 2 multiply कर देना, 2p by pi into diameter and length of the core sample. Are you getting my point, or if you have any doubt then tell me. नहीं है डाउट? आई ऑलवेज रिमेम्बर न्यूटन पर मीटर स्क्वायर क्या होता है? PFN है. न्यूटन पर मीटर स्क्वायर क्या है होता है नॉर्मली? टेल मी रूबी. Newton. Exactly, it is Pascal, right? Stress, the unit of stress is Pascal. 1 megapascal कितना पास्कल होता है? वन गीगापास्कल कितना पास्कल होता है? राइट? ये सुनो. सो इतना याद रखना, न्यूटन पर मीटर स्क्वायर इज ओनली पास्कल. ओके, इफ द क्वेश्चन आस्क इन द पास्कल, अगर क्वेश्चन पास्कल पे पूछेगा, देखो यहाँ पे तो किलो न्यूटन है ना, है कि नहीं? यू हैव टू कन्वर्ट इनटू द न्यूटन. यस और नो? अगर डायमीटर मिलीमीटर पे यू हैव टू कन्वर्ट इनटू मीटर. यस और नो? सो दिस वे ओनली, ऑलवेज रिमेंबर दिस पार्ट ओनली, कि क्वेश्चन पास्कल पे पूछा है या मेगा पास्कल पे पूछा है या जीगा पास्कल पे पूछा है, राइट? ऑलवेज रिमेंबर दिस पार्ट. दिस इज रियली इंपॉर्टेंट फॉर द कंबस्टन. एक्चुअली माई हेल्थ इज नॉट दैट मच गुड. हाँ, क्या बताओ? Okay, I always give this importance of this conversion also. Kilowatt to bar, right? Bar to Pascal. So that is should be remember. Any doubt till now? Then कल इसको engineering geology को complete करते हैं by like rock mass classification. ठीक है, कल करते हैं, then we'll done. Any doubt till now?